A very good morning to you, my dear children. Today we are going to discuss on the topic, how strong are acid and base solutions? Okay, let me clear. For example, you are provided with 4 solutions. Okay, one is hydrochloric acid. Okay, second one is carbonic acid. Third one is a base, sodium hydroxide. Fourth one is magnesium hydroxide. Okay. Now, you know that hydrochloric acid is a strong acid, carbonic acid is a weak acid, sodium hydroxide is a strong base, and magnesium hydroxide is a weak base. Okay. And now, suppose you are asked to find out which among this is a strong acid, weak acid, strong base and weak base. You know that by using a simple indicator like phenolphthalein, methyl orange, litmus solutions or litmus papers, blue and red litmus papers, or any other natural indicators, olfactory indicators, natural indicators like turmeric, red cabbage, etc., olfactory indicators like onion, clove, vanilla essence, etc. You can find out only whether the given solution is acidic or basic. You cannot find out the strength of acid or the strength of base. Did you understand? Which among this is a strong acid? Which among this is a strong base? You cannot find out with a simple indicator. To know the strength of the acid, we have another type of indicator which is called universal indicator. Okay. So today we are going to discuss about universal indicator. Universal indicator. Let's see how does a universal indicator work. See here, universal indicator uses a pH scale. Okay, pH scale means, let's see what is pH. P is a German word. Okay, potens indicates potens. Potens means power. Okay, and H, hydrogen. So what is pH? Power of hydrogen, right? Power of hydrogen. We know that the strength of acid is decided by the number of H plus ions released per unit volume. That means in the previous class we have already discussed about strong acid, weak acid, strong base and a weak base. How can we categorize or classify strong acid and a weak acid? For example, if you take hydrochloric acid, in aqueous solutions, hydrochloric acid will completely ionize into H plus ions and Cl minus ions. So the number of H plus ions produced per unit volume will be more as it is completely ionizes. In the case of a weak acid like carbonic acid, it can only partially ionize. Therefore, the number of H plus ions produced per unit volume will be less compared to a strong acid. Similarly, in a strong base and a weak base, if you take same concentration of a strong base like sodium hydroxide and a weak base like magnesium hydroxide, the number of H plus ions, OH minus ions produced will be per unit volume will be less for a weak base and more for a strong base as it completely ionizes. Is that clear? In the previous class, it's clearly explained for you. So you know what is a strong acid, weak acid, strong base and a weak base. Okay. Now here the pH, in the pH scale, there are some numbers ranges from 0 to 14 and colors ranges from red to purple. Remember, if universal indicators are available in both the forms and paper strips and also solutions like red litmus and blue litmus solutions are available, also strips are available. You know that, right? So suppose you have got a universal indicator paper for testing solutions like hydrochloric acid, carbonic acid, sodium hydroxide, magnesium hydroxide, strong acid, weak acid, strong base, weak base. Okay. Now, if you dip universal indicator paper in a neutral solution like water, the number shown will be 7 and the color will be green. Okay, the strip will show green color and the number indicates 7, which is neutral. So here 7 indicates neutral solution like water or salt like sodium chloride solution, etc. will show only neutral 7, the value 7 and green color. Okay, but when you move from 7, that means this side, left side, from 6, 5, 4, 3, 2, 1, 0, acidic nature increases. Acidic nature increases. That means if you got a strong acid like hydrochloric acid and if you dip a universal indicator paper in hydrochloric acid, it will show red color and a value 0 because it is most acidic nature. So acidic nature increases. Now if you get a weak acid, you will get the value 5 or 6 near to neutral and the color will be yellow. Clear? Similarly, if you move away from 7 to right side, the basic nature increases. That means if you dip a universal indicator paper in a strong base like sodium hydroxide solution, it will show number 14 and dark purple color because it's a strong base. So the basic nature increases when you move right side. And if you got a weak base like magnesium hydroxide, you will get a blue color or the number 9 or 8. Okay, so which is a weak base. Hope you understood how can we use universal indicator paper and universal indicator solution for finding out the given solution is the strength of the given solution. Okay. Okay. Now let's check what is the importance of pH in our everyday life. Okay. Now I have written on the board some points. First one is what is the importance of pH in plants and animals. You know that for human beings, our body metabolism works in a very narrow range of pH, that is 7 to almost neutral. 7 to our body functions in between the range of pH 7 to 7.8, almost neutral, isn't it? If the pH varies, if the pH goes below 7 or goes above 7.8, what will happen? Our metabolism will become improper, which causes a lot of problems in our body. So pH for human beings, the range of pH to balance it as neutral is very important in human beings. Okay, let's think about plants. Plants, you know that they are growing in soil, right? So the pH of soil is very important. If the pH of soil goes too acidic or too basic, plants cannot survive. So what the farmers can do, if the soil becomes too acidic, they will add some bases like mild bases like calcium hydroxide or calcium carbonate to the soil to neutralize the excess acid. If the soil becomes too acidic, they will add some acidic salts like gypsum, etc. to the soil to neutralize it. Okay, so remember, plants are also very sensitive for pH change. And what about aquatic animals? Okay, now you know that rain becomes acidic. If the pH of rain goes below 5.6, then we call it as acidic rain, acid rain. Okay. Now, if they fall in river, water bodies, river, pond, etc., what will happen? The aquatic life, the aquatic plants and aquatic animals, the life of aquatic organisms will become very difficult. Okay. So, they are also very sensitive for pH change. Okay. Now, next, digestive system. We know that we have strong hydrochloric acid in our stomach, which helps in digestion. Okay. If the acid produced becomes too high in our stomach, we will feel a burning sensation, which is called acidity. So, what is the remedy for acidity? That time we are taking a medicine called antacid. What is that? Antacid. Antacid contains mainly magnesium hydroxide, which is a mild base. So, if you take antacid, meaning magnesium hydroxide, that base can neutralize the excess acid produced in our stomach. Okay. So, what is the chemical? What will be the chemical reaction? Hydrochloric acid plus magnesium hydroxide will give you the salt, magnesium chloride and water. So, the excess acid will be neutralized. This chemical reaction is not balanced. Try to balance this chemical reaction. Homework for you. Okay. Now, let's move to the next one. What is the third one? Tooth decay. You know that our tooth is made with an enamel, right? Which is the hardest substance in our body. What is that? Calcium phosphate. Tooth enamel is the hardest substance in our body. Tooth enamel. Okay. Now, how does a tooth decay occur? If we eat, okay, and if we, after eating, if we do not clean brush our teeth properly, the food remainings and sugar will stay in our mouth, and the bacteria present in our mouth will start to degrade the sugar and food particles and produces acids. Okay. So, what will happen? This acids will react with calcium phosphate, the enamel, tooth enamel, and the tooth enamel starts to corrode. As a result, what will happen? Tooth decay will occur. Now, very sensitive. The pH way, our mouth is very pH sensitive. If the pH of our mouth goes below 5.5, tooth decay can start. Tooth decay occur. So, what is the remedy? Neutralize with a base. So, toothpaste is basic in nature. That is why it is advised to brush twice, minimum twice in a day. Is that clear to you? So, our mouth is also sensitive for pH. Now, the last one, self-defense mechanism by animals and plants. Okay. Have you ever stung by a bee or any insect? We feel that they are injected. When an insect bites you, an insect is injecting methanoic acid into your body, formic acid or methanoic acid, which will cause irritation and pain. So, what is a home remedy for that? Applying a base on the site of a bite for neutralizing the excess acid produced. So, you can use a mild base like baking soda or baking powder for rubbing on that area. Clear? Which will reduce the pain and irritation. And also in plants, nettle plant, we are calling it as tuva. Tuva we will call it in Malayalam. That is, when you touch that one, you feel irritation because they are also producing methanoic acid. So, which will causes skin irritation. What is the home remedy? Same thing. Try to neutralize that with a mild base like baking soda or baking powder. Okay, is that clear to you? Now we are going to discuss the question answers after this pH scale. Okay, let me take the textbook. Okay, we are going to discuss page number 28. 4 questions are there. Page number 28. Question number 1. You have 2 solutions, A and B. pH solution of A is 6. pH of A is 6. The pH of solution A is 6 and pH of solution B is 8. Okay. Which solution has more hydrogen ion concentration? Which of this is acidic and which one is basic? Which one is having more hydrogen ion concentration? So we know that as we move away from 7, number decreases, the acidity increases, isn't it? So 7 is coming in between. So this is an acid and this is a base, right? So 6 is acidic, the value 6 is for an acid. So solution A is acid and B is basic. Okay, and hydrogen ion concentration is more for A because it is an acid. What effect does the second question? What effect does the concentration of H plus aqueous ions have on the nature of the solution? So when number of H plus ions increases per unit volume, what will happen to that solution? Acidity of the solution increases, or the strength of acidity increases when H plus ions per unit volume increases. Is that clear? It will become a strong acid. Now, third question. Do basic solutions also have H plus aqueous ions? If yes, then why are these basic? Okay. Now, remember, basic solution can also release H plus ions, but the number of OH minus ions are more, okay, per unit volume compared to H plus ions. Therefore, it is called basic. So, acidic solution and basic solution, how they are classified, which number of ions are more, okay. If a solution releases more H plus ions than compared to any other ions, whether it be OH or any other ions, it is an acid. And if a solution releases more number of OH minus compared to any other ions, like it be H plus or any other ions, the solution becomes more acidic. So, a basic solution can also produce H plus ions, but the number of H plus ions will be very less compared to OH minus ions. That is why it is called a base. Clear? Okay. Fourth question. Under what soil condition do you think farmer would treat the soil of his fields with quicklime? What is quicklime? Calcium oxide. Or with slaker lime, calcium hydroxide, or with chalk, calcium carbonate. Farmers are sprinkling sometimes calcium oxide, calcium hydroxide, or even calcium carbonate under what conditions? We know that these three are weak bases, right? So what will be the soil condition when the farmer decided to treat with a base? Definitely when the soil becomes acidic, to neutralize the excess acid produced in the soil, farmers can use weak bases like calcium oxide, quicklime, calcium hydroxide, slaker lime, calcium carbonate, limestone. Common name. Okay, you know that. Quicklime, calcium oxide, quicklime, calcium hydroxide, slaker lime, and calcium carbonate, limestone. Okay, so that's all about today's class. We will see in the coming classes, online classes. Till then, have a nice day and take care. Bye-bye.